Hello everyone, my name is Saif. Welcome to a new short series of videos or lectures which covers photovoltaic systems. So a comprehensive explanation of photovoltaic system components and a couple of system design procedures will be presented in this series. Today's video will cover these topics. First, technologies or systems which utilize solar energy will be presented briefly, including concentrated solar power, brief introduction to solar radiation, PV system components and the classification, and then we'll start with the first component of any PV system, which is the photovoltaic cell and therefore photovoltaic module. Technologies which convert solar energy to electrical energy can be divided to two types. In the first type, solar energy is converted directly to electrical energy. These systems will use photovoltaic phenomena, and it will be the topic of the second part of this video. The other type of technologies convert the solar energy into a thermal energy, and then in a similar way to conventional power plant, the thermal energy is converted to electrical energy. All types of renewable energies have witnessed a large decline in the cost of generation from these sources, mainly photovoltaic systems concentrating solar power, onshore and offshore wind turbines. The price presented in this figure represent utility scale projects. Basically, it's mega size projects, and the price is the global levelized cost of energy in US dollar per kilowatt hour. Now this price witnessed a large drop over the last 10 years from around 40 cents per kilowatt to around 5 cents, which is 80% decline over the last 10 years. The price drop is due to two factors. First is the capital cost or cost of installing those systems, which declined from 4,700 US dollar to less than 1,000 globally, and capacity factor, which is basically the ratio of the generated energy of that system over a certain period of time to the maximum possible energy generation over the same period of time. This capacity factor also witnessed an improvement due to increased efficiency of PV systems, particularly PV modules. Similarly, concentrating solar power have witnessed a decline in its levelized cost of energy due to the same factors, and consequently over the last 10 years the share of electricity consumption where renewable energy was the source, consequently the share of electricity generated from renewable energies over the last 10 years have risen from around 1% to around 10% around the world. Concentrated solar power systems can be divided to two types. In the first type, the solar energy or solar beam is concentrated into a linear path, such as linear frenzel or parabolic trough. In the second type of systems, the solar beam is concentrated into a point, such as parabolic dish systems and solar power tower systems. In this video, we're going to present parabolic trough and solar power tower systems briefly, as those two systems have reached a wide commercial use. Parabolic trough system consists of a field of rows, each row with parabolic trough shaped mirror or mirrors with a tube along its linear parabola focal line. The mirrors and the tube are mounted on a system which track the sun on one axis from east to west. Within the tube, a synthetic oil which collect the solar radiation in the form of thermal energy. This thermal energy is then transformed to the power block, where a heat exchanger produces steam, which drive a steam turbine to generate electricity. This oil is acting as a thermal buffer to eliminate any temperature instability in the solar field and allow the steam and therefore the electricity generation for a couple of minutes before any clouds can affect the power generation of the system. Additional thermal storage in the form of 2 tanks with melted salt, usually installed in this system in order to allow electrical energy generation when the sun is not available for a couple of hours. Some of those systems as well use natural gas to generate steam when the sunlight is not available, and therefore facilitate the electricity generation for 24 hours. And alongside the thermal storage, the system has the advantage of being dispatchable for a long period of time and in a similar manner to conventional power systems. The second type of concentrating solar power is power tower system or solar tower system, where the solar field of mirror placed on a 2-axis tracking system reflect the solar beam into the top of that tower, which when the tower is placed at the center of that solar field is consist of a cylinder which collect the solar energy from all directions and convert it to a thermal energy. That thermal energy is then transformed to a heat exchanger to produce steam that drive turbines and generate electricity. Similarly, this system usually include thermal storage in terms of a molten salt, which usually consists of sodium and potassium salts, and behave in similar way to the parabolic trough systems, and sometimes equipped with a steam generator from natural gas to ensure steam and therefore electricity generation 24 hours. Sunlight received at the Earth's surface is composed of 3 components: direct radiation, diffused radiation, and reflected radiation. Sometimes reflected radiation is also called albedo. Radiance received at the top of the atmosphere at the side facing the sun is 1367 watt per square meter, which is also called solar constant, which is the instantaneous quantity, and it's also often called intensity of the sunlight. When the sunlight transfers through the atmosphere to the sea level at the sun directly overhead, or the sunlight is perpendicular to the Earth's surface, that solar constant reduced to 1000 watt per square meter. The energy density or irradiation is the integration of a radiance over a certain period of time, so it can be an hour or a day, is measured by the unit of kilowatt hour per square meter. Now, most of PV modules contain a plate with an important indices or numbers given at a certain conditions, often called standard testing conditions, which is basically 1000 watt per square meter as a solar irradiance. AM equals to 1.5, so AM is the air mass coefficient, and at a PV cell temperature of 25 Celsius. Now the air mass coefficient is the ratio between the sunlight path going through the atmosphere and hitting the earth at a certain angle, which is called zenith angle, to the sunlight path going through the atmosphere perpendicularly, so at zenith angle equals 0 or at the zenith, also at sea level. That coefficient usually set to 1.5, which refers to that the sun path hit the ground with a zenith angle equals to 48 degrees. Now we will talk more about angles related to PV systems when we design PV system, so that to measure the tilt angles or the angles of the modules with respect to ground, as well as spaces between PV panels. Each PV system consists of some or all of those parameters, essentially PV module, and most of the times inverter as well, which converts the direct current generated from solar cells or PV module to alternating current. And sometimes PV systems consist of batteries and therefore charge controllers for those batteries, in addition to other components in some references called balancing of the system components, mainly the mounting structure and sometimes tracking system to change the angle at which the modules facing the sun. Now the cost of PV systems, as we mentioned earlier, dropped by 80%. That reduction is mainly due to the reduction in PV modules in addition to inverters, which is around 60%. Yet the other costs such as installation, inspection, and soft costs were or are witnessing a reduction as well. This figure is for utility scale PV systems, so systems with capacities of megawatts. Now, PV systems can be classified based on their connection to the power grid or to the electrical grid, and in this case the generated electricity is synchronized with the electrical system, and therefore PV systems can be divided to off-grid or standalone systems, on-grid or grid-tie systems, and each of them may or may not include batteries. Hybrid PV systems are systems with or without electrical grid. Now this and the following slides consist of a very simplified scheme of PV systems for demonstration only. The detailed connection or schematic diagram will be presented in next lectures when we talk in details about PV system design. But basically, for a grid connected or grid tied PV system, PV array is a must. An inverter to convert DC to AC voltage with a frequency equals to the electrical power system. And when load consumption is smaller than generated electricity from PV system, the rest is exported to the electrical power system. And when the consumption of the connected loads are bigger than the generated PV output, the power flow back to the loads from electrical power system in a similar way to conventional flow of electricity. And hence the electrical power system is acting as a buffer to supply the difference between or cover the difference between loads consumption and PV generation. In some grid tie PV systems on energy storage or a battery bank connected to ensure that all of the PV generation is utilized and the fewer electrical generation from that PV system is exported to the electrical power system for economic reasons, and the same structure is applied to a hybrid on and off grid system which requires batteries as well. And in this case, battery or energy storage system is acting as the buffer to match the power generation from PV system with the energy consumption from loads. In standalone systems or off-grid system, batteries are an essential component since there is no electrical power system to cover whatever energy needs required by loads which PV system cannot provide instantaneously, and to ensure power supply to loads in early morning when the sun is not available or the power generation is not enough, or in night time. Now some of the irrigation systems, usually in rural areas, are utilizing or using PV systems to operate. Those irrigation systems, mainly the water pumps, are either with DC or AC source, and we will talk about irrigation systems powered by a PV system in another lecture when we discuss irrigation systems with DC and AC PV systems. Now the backbone of PV systems is the solar cell or PV cell. In a typical solar cell of silicon material, two layers of silicon is present. The first layer is silicon doped with phosphor, and therefore it has extra holes to share, and silicon doped with boron, and therefore it has extra electrons to share. when the sunlight hit the solar cell, the electron migrated through the p-n junction, and a potential difference across the cell is presented. For a typical silicon cell, it's around half a volt, and current can go through that external circuit carried by the connection strips, commercially known as busbar or busbars. Photovoltaic cells went through development through 3 generations, yet PV modules available commercially dominated by the first generation, which consists of silicon cells sliced from a single crystalline wafer or a wafer of many small crystalline grains of silicon, hence a monocrystalline and polycrystalline cells. In the second generation, thin film technology is applied, which make the process of manufacturing PV modules much cheaper, yet the efficiency is reduced. In the third generation, multi-junction instead of single junction cells are created, yet cells made of multi-junction are still expensive, and the use of such cells is currently limited to applications related to satellites and cells, which has an efficiency of more than 40%. In comparison, the first generation theoretical efficiency is around 30%. The second generation efficiency is less than that. That efficiency is reflecting the amount of solar energy converted to electrical energy. Now, since each cell generates a small amount of power and with a small potential difference, many cells are connected in series to build one PV module. PV modules available in the market consist of 60 cells or 72 cells. For comparison, a PV module made of second generation technology, thin film technology, will require bigger space to generate the same energy which can be generated from the first generation of silicon cells. 2 important curves describing the behavior of photovoltaic cell. The first one is IV curve. The second one is the PV curve, which is the product of the current multiplied by the voltage. And the indices presented in the nameplate at the back of PV module we've talked about early consist of indices presented by those 2 curves, the value of the short circuit current and the open circuit voltage. IV curves are affected deeply by 2 parameters, the temperature and the irradiance. The temperature affects the IV curve in terms of reducing the open circuit voltage and therefore reducing the power produced by the cell when the temperature increases. The second factor is irradiance. When the irradiance reduced, the short circuit current is reduced as well, and therefore the output of that cell is reduced. Since the temperature and the irradiance varies around the day, and in order to capture the maximum power from each cell, the maximum power point changes, and the system have to track that point continuously. As we mentioned, each PV module consists of several cells connected in series. IV curve of the combination is changing accordingly. When more than 1 PV module are connected in parallel, their combined IV curve is changing as well. A typical PV module, which usually has a 25 years lifetime, consists of several layers. At the center, the solar cells, sandwiched between 2 layers of materials such as ethylene. Different manufacturers have different materials, of course, with a layer of a glass to allow the sunlight into the cells, and a back layer of plastic or other material to protect the cell from humidity and other types of stress, surrounded by a frame typically made of aluminum to enhance the mechanical strength of the module. Of course, these PV modules have to stand different types of thermal, mechanical stress over its lifetime. At the back, a junction box where the connection cables exit to be connected to the rest of the system. In addition, it consists of a couple of diodes, typically 3 diodes, which called bypass diodes. These bypass diodes have an essential role in the healthy operation of PV module. So in the presence of a shade which covers one of the cells of the module, and since all of those cells are connected in series, the shade causes the current through that cell and all cells connected to it in series to drop significantly. And therefore, with the bypass diode connected to a group of cells, the energy drop due to that shade is reduced. So instead of losing almost all of the generation from that module, the loss is limited to the third of that module in case of having 3 diodes covering the 3 parts of that module. One of the technologies being adopted widely recently by PV modules manufacturers is the half cell or half cut technology, since the electrical losses through conductor resistance proportional to the square of the current going through that conductor. Halving the current means reducing the losses 4 times, which improve the energy yield from PV module. In addition, the impact of shade affecting modules is reduced to half. So in conventional 60 cell module, when the shade affecting one of the cells, 1/3 of the energy is lost. But in a 120 half cell PV module, when a shade affects one cell, the energy losses is reduced to half. The second technology being adopted by manufacturers is bifacial PV modules. Basically, the back of each module is made transparent in order to observe the light from the back of the cell, in addition to the light observed from the front of the cell or module. The increase in the energy due to light observed from the back of the module is highly dependent on the surface lies behind that module. So for example, if it's a white paint, the energy increased by almost 20%. Different, less reflective surfaces leads to an increase in energy, but in a smaller amount. Now, when a couple of PV modules connected in series, the combination is called string, and when a couple of strings are connected in parallel, a PV array is built. If a couple of modules are mounted on one rack, it's called PV panel. These are the references cited in this lecture or video. As I mentioned, this is the first lecture of a short series. The next lecture will cover batteries and inverter. If you like to follow this series, please subscribe, and if you have been, thank you for watching.